Welcome to another episode of Microsoft Knowledge Nuggets here on M365 FM. I'm Milco Peters, and today's topic is one that almost everyone has heard of, but few people actually understand: Azure ExpressRoute. What exactly is it? Is it just a fancy VPN, or is it something completely different? Imagine you start a new company tomorrow. You rely on cloud apps, file sharing, and remote work. Every day, your connection to Azure goes over the public internet. That's like taking a highway with unpredictable traffic. It works fine for checking email. But when you move critical data or run real-time applications, speed and reliability start to matter a lot. Azure ExpressRoute is the private lane, a dedicated physical link from your office or data center directly into Microsoft's network. By the end of this episode, you'll understand what ExpressRoute actually is, how it's built, and whether your business should use it instead of a regular VPN. The private highway analogy. Let's picture the public internet as a busy two-lane highway shared with everyone. Deliveries, commuters, and sightseers all clog the same road. Your data packets get stuck in that traffic. Every time someone streams a movie or downloads a large file, your business traffic slows down. That's the reality of sharing the road with the entire world. ExpressRoute creates a private, reserved lane that connects your on-premises network directly to Azure, so your traffic bypasses the internet entirely. That means consistent speed, lower latency, and higher security because your data never touches the public road. This isn't magic. It's a physical or virtual connection made through a partner like Equinix, Megaport, or directly with Microsoft via something called ExpressRoute Direct. The result is predictable performance with no bandwidth fights and a Microsoft SLA that guarantees uptime. Here's the thing, this is the big idea: a private connection instead of a public one. Everything else is just detail. Once you understand that, the rest of ExpressRoute makes sense. Building blocks: circuit, peering, gateway. So how does that private highway actually get built? Let's break down the main components. An ExpressRoute circuit is the core, the physical cable or virtual link you order from a provider. It comes with two connections for built-in redundancy. If one link fails, the other keeps working. That's built into every circuit by default. On top of that circuit, you configure something called peerings. These are separate doors that allow different types of traffic, and there are two main ones you need to know about. Private peering connects to your Azure virtual networks. That's where your VMs, databases, and internal applications live. This is the door you use for your private workloads. Then Microsoft Peering connects to Microsoft's public services like Microsoft 365, Dynamics 365, and Azure Public Endpoints. That's the door for accessing SaaS applications and other Microsoft services. Now, to connect the circuit to your Azure virtual network, you need an ExpressRoute virtual network gateway. Think of it as a special router that lives in your Azure network and speaks a language called BGP, Border Gateway Protocol, with the circuit. BGP is how both sides share routing information automatically. No manual route tables needed. The gateway comes in different sizes: standard, high performance, ultra performance, depending on how much traffic you expect. There's also Fast Path, an optional feature that lets traffic bypass the gateway for even lower latency on high-speed circuits. If you're running at 10 gigabits per second or higher, Fast Path can make a noticeable difference. These three pieces, circuit, peering, gateway, form the complete private highway from your office to your cloud workloads. Each plays a specific role, and together they create a connection that's reliable, fast, and secure. Two ways to connect: provider versus direct. Most businesses go with the provider-based model. You work with a telecom partner like AT&T, Verizon, or a cloud exchange provider like Megaport or Equinix. The provider handles the physical connection from your location to the nearest ExpressRoute peering location, and that's a Microsoft Edge site where the actual handoff happens. You just give them a service key from your Azure portal, and they take care of the rest. This approach is simpler and faster to set up. It supports bandwidth from 50 megabits per second all the way up to 10 gigabits. The provider manages the middle mile, so you don't need to worry about the physical infrastructure between your office and Microsoft's network. The alternative is ExpressRoute Direct. With Direct, you get two physical ports at a peering location. We're talking 10, 100, or even 400 gigabits per port. Direct is for high-volume scenarios like huge data migrations, regulated industries that need physical isolation, or connecting multiple clouds through a single set of ports. Here's the trade-off. Direct gives you more control and higher speeds, but you're responsible for managing the physical connection yourself. Cross connects in the data center, coordinating with the facility, and handling any gear issues. For 90% of businesses, the provider model is the right choice. Direct is for the top tier, organizations that need maximum throughput or have specific compliance requirements. Staying connected, resiliency and redundancy. Every ExpressRoute circuit comes with built-in redundancy, two physical connections to two separate Microsoft Edge routers. If one link fails, the other keeps your traffic flowing. That's the default. But here's the thing, Microsoft wants you to think bigger. The real danger isn't a single broken fiber, it's losing an entire peering location. Imagine a fire in the data center, a construction crew cutting the main fiber, or a power outage that takes out the whole facility. That's the kind of event that kills a single circuit. Even with redundant links, you have three levels of resiliency to choose from. Standard is what you get by default. 2 links in one peering location. High resiliency gives you 1 link in each of 2 different peering locations within the same metro area. Maximum resiliency goes all the way. 2 separate circuits in 2 different peering locations, each with its own pair of links. That's the gold standard. You can lose an entire peering location and still have connectivity running. Why does this matter? Because ExpressRoute often carries mission-critical workloads. Downtime means lost revenue. A hospital can't afford to lose access to patient records. A trading firm can't afford even a few seconds of interruption. So the extra investment in redundancy makes sense for those scenarios. You can also pair ExpressRoute with a backup VPN as a lower-cost failover option. When ExpressRoute is down, the VPN handles less critical traffic or serves as a backup path for essential services. Many enterprises use this hybrid approach. ExpressRoute for the important stuff, VPN as a safety net. The key takeaway is simple. Don't assume one circuit is enough. Plan for the unexpected. Your connection is only as reliable as your weakest link. ExpressRoute versus site-to-site VPN. Here's a question I hear all the time. Both services connect your on-premises network to Azure, but they work very differently. A VPN uses the public internet. Your data is encrypted, so it's secure in transit. But you're at the mercy of internet congestion, ISP routing decisions, and variable latency. The highest VPN gateway SQ tops out around 1.25 gigabits per second. That's fine for many scenarios, but it's a hard ceiling. ExpressRoute is private, no internet involved. Latency is predictable because your traffic stays on Microsoft's backbone network. Bandwidth goes up to 100 gigabits per second. Microsoft guarantees 99.9% uptime for the connection itself. Cost is where the rubber meets the road. VPN is much cheaper. A typical small to medium business pays double to low triple digits per month for their VPN gateway. ExpressRoute starts around high triple digits and can climb into thousands, especially once you add provider fees. The provider charges for the physical connection, the cross connects, the last mile circuits, the port fees. Those costs often exceed what Azure charges for the circuit itself. Setup time is another big difference. VPN can be provisioned in hours. You create the gateway, configure the tunnel, and you're done. ExpressRoute takes days to weeks because the provider must physically configure the connection. You can't speed that up. Security works differently too. VPN has built-in IPsec encryption. Your traffic is encrypted end-to-end. ExpressRoute gives you a private path, but it doesn't automatically encrypt everything. If you need encryption over the private link, you need additional measures like MACsec on ExpressRoute Direct. For most businesses, the private path alone is sufficient. But if your compliance requirements demand encryption at the network layer, you need to plan for it. So when do you use each one? VPN is great for test and development environments, small offices with light workloads, or as a backup connection. ExpressRoute is for production systems, high bandwidth applications, compliance-driven environments, or anything latency sensitive. Many enterprises use both. VPN for less critical traffic, ExpressRoute for the important stuff. The takeaway is straightforward. VPN is good enough for a lot of scenarios. ExpressRoute is overkill unless you really need the performance, the predictability, or the compliance benefits. Don't pay for a private lane if a public road works fine. When real businesses use ExpressRoute. So where does ExpressRoute actually make a difference? Let's walk through some real-world examples where the theory becomes practical. Healthcare is a big one. Think about a hospital that needs to move large MRI and CT scan files from on-premises storage to Azure for analysis. Over the public internet, variable latency can slow things down. A radiologist waiting for images to load isn't just frustrated, they're potentially delaying patient care. ExpressRoute gives them consistent speed so those images arrive exactly when expected. Finance is another clear example. Trading applications need low, predictable latency. Even 20 milliseconds of jitter can cost real money. In high-frequency trading, that's the difference between executing a trade and missing the window entirely. ExpressRoute gives them a guaranteed path with performance they can count on. Now let's talk about manufacturing. Factories with IoT sensors send continuous data streams to Azure, and an internet interruption could shut down a production line. If a sensor stops reporting, the system might assume a machine is down and trigger an emergency stop. ExpressRoute provides the reliability those continuous data streams need to keep everything running. Disaster recovery is a big use case. Organizations replicate entire data centers to Azure, which means moving terabytes of data continuously. ExpressRoute provides the high bandwidth and SLA needed for synchronous replication. With a VPN, you might struggle to meet your recovery time objectives because the connection simply can't handle the throughput. Large data transfers are another place where ExpressRoute really pays off. If you're moving terabytes or petabytes to Azure, media files, research data, historical archives, the unlimited data plan on ExpressRoute can actually be cheaper than paying internet egress fees. At scale, the math flips. The fixed cost of the circuit becomes more economical than paying per gigabyte for massive data transfers. There's also multi-site connectivity. With ExpressRoute Global Reach, you can connect 2 remote offices using the same circuit, routing traffic across Microsoft's backbone instead of going through Azure. That can replace or supplement a traditional WAN connection for some scenarios. These are the situations where the extra cost of ExpressRoute pays for itself. Avoided downtime, faster operations, and compliance requirements met. When you run the numbers, the question flips. It's not, can I afford ExpressRoute? It's, can I afford not to have it? The provisioning process. So you've decided ExpressRoute makes sense. How do you actually get one? This is where a lot of people get confused, because it's not like flipping a switch, it's a two-step process. Step 1 happens in Azure. You create the ExpressRoute circuit in the portal. This part is fast. The resource appears in minutes. You give it a name, pick your bandwidth, choose your provider. But here's the catch. The circuit exists in Azure, but it's not usable yet. It's like ordering a highway exit that hasn't been built. Step 2 is where the real work happens. You take the service key from your circuit, that's a unique identifier, and you give it to your provider. They then configure the physical connection from your location to the Microsoft Edge router at the peering location. This is the part that takes time. Days, sometimes weeks. It depends on the provider's backlog, whether cross-connects need to be patched manually, and whether there's available capacity at the peering location. Once the provider finishes their work, the provider status in Azure changes from not provisioned to provisioned. That's your signal that the physical connection is ready. Only now can you configure peerings and connect it to your virtual network gateway. After that, you create a connection object that links the circuit to your gateway. The BGP session establishes automatically and routes start flowing. Your private highway is open for business. Total time? Azure side, hours. Provider side, potentially weeks. The lesson is simple. Plan ahead. Don't wait until you need the connection to start the process. Order your circuit weeks before your migration window. Is it right for you? After everything we've covered, the big question is, should you actually get ExpressRoute? Let's be honest about it. Start by looking at what you really need. If you have workloads demanding consistent latency or high bandwidth, ExpressRoute might be worth it, but if you're just moving small amounts occasionally, a VPN does the job just fine. For a small business with a few users and cloud apps, ExpressRoute would be overkill and too expensive. Don't let marketing convince you that you need a private highway when a regular road works fine. Now, if you're a mid-size or enterprise company running critical applications in Azure, or you have compliance requirements or healthcare, finance, government, that's when ExpressRoute starts to make real sense. The cost becomes an investment in reliability rather than just an expense. Here's a practical approach. Start with a smaller circuit, say 50 to 100 megabits, and pair it with a backup VPN. That keeps costs down while giving you a private path when you need it. You can always upgrade the bandwidth later without tearing down the connection. And remember, ExpressRoute isn't an all-or-nothing decision. Many companies take a hybrid approach. Private circuit for critical traffic, public internet for everything else. You don't have to route all your traffic through ExpressRoute, just the stuff that matters. The right answer depends on your performance needs, your budget, and your tolerance for risk. Be honest about what you actually need and choose accordingly. So that's ExpressRoute, a dedicated private link from your network straight to Azure, completely off the public internet so you get no traffic jams, built with redundancy, high bandwidth, and an SLA. But it costs more and takes longer to set up than a VPN. For many, a VPN is enough. For others, this private lane is essential. Know your workloads, choose smart, and subscribe to Microsoft Knowledge Nuggets for more plain English breakdowns like this one.